This question is a geometric induction question. Remember, for geometric questions, the diagram is key. So we need good diagrams here. This question comes directly from the 4-unit syllabus. Prove the sum of the exterior angles of an n-sided plane convex polygon is 360 degrees. Okay, just a quick recap. Convex means that the interior angles are non-reflex. Interior angles non-reflex. Okay, or sometimes another way of describing that is that the diagonals of the polygon are internal, don't go outside the polygon. Alright, so we first start off with test. We can't have a one-sided polygon or a two-sided polygon. The lowest sided polygon is a three-sided polygon, which is a triangle. So let's just draw a triangle here. Okay, there's a triangle. Now to draw the exterior angles, I'm going to extend the sides of the triangle, and then the exterior angles are the ones that go around in the same direction and are not the straight angle bit. So I'm going to call them alpha, beta, and gamma. Alpha, beta, and gamma. So we're required to show that alpha plus beta plus gamma should equal to 360 degrees. Okay, in order to do that, I'm going to call the internal angles A, B, C. Okay, and then we're going to use the fact that alpha is 180 minus A, Y, straight angle. Okay, similarly, beta will be 180 degrees minus B, and gamma will be 180 degrees minus C. So if we now add, so we want to work out the sum of the exterior angles. That's alpha plus beta plus gamma. Well, that'll be 180 degrees minus A plus 180 degrees minus B plus 180 degrees minus C. So that's going to be, if you add up, 540 minus bracket A plus B plus C. Okay, and then A plus B plus C is the sum of the interior angles of a triangle, which we know is 180. Okay. I'll write angle sum of triangle. Simplifying, this is equal to 360 degrees. Okay, so therefore we know the result is true for n equal to 3. Okay, so we've tested the base case, the initial case. Now, next step for induction is to assume true for n equal k. And obviously k is going to be an integer, and it's going to be greater than or equal to 3. So what does this mean? I'm just going to write it as a statement that the exterior angle sum of k-sided polygon, I'm going to add the word convex there because that's in the question. Convex polygon is 360 degrees. Okay. So let's assume true for n equal k. Now we're going to prove true for n equal k plus 1. So write down what we're required to prove. So RTP, exterior angle sum of k plus 1 sided convex polygon is 360 degrees. Okay, now here comes the diagram, which is the key part to the induction. and you need to work out a nice way of drawing this diagram. Okay, so what I'm going to do is I'm going to kind of draw remember to draw a k-sided. I'm going to draw the assumption first, and then I'm going to draw the RTP. So I'm going to draw a k-sided first. Okay, let's draw like this. I'm going to draw the external angle like that. Okay. Yeah, I'm going to do lots of dots. And these dots basically mean I don't know how many sided it is, okay? But this undotted bit will be a key focus. So that's going to be our k-sided polygon. And remember, to get a k plus 1 sided, you're going to remove one of these sides and add 2. Okay, so I'm going to remove a particular side and add 2. So I'm going to be very careful about how I do this. So the side that I'm removing, I'm going to dot. So I'm going to try and copy so it looks like the previous image with the dot. Okay, I'm gonna create an extra side there. Okay, it's still got this side here. Okay, so you can see I've removed one side and added 2. So this will be a k plus 1 sided polygon. And the key thing is we need to consider exterior angles here. Exterior angle here, which will be here. Exterior angle here. Alright, I want us to have a close look at what's changed. So before, the exterior angles were here. Now notice that this exterior angle matches that one, so that's okay, that's the same. But there has been a bit of a change if you compare the k to k plus 1 case. There's been a little bit of a change. Convince yourself that what was this big angle has now been reduced. Okay, so I'm going to call, let's call this one alpha. That guy's gone. Okay, it was in the kth case, but it's not in the kth plus 1 case. Also, what's been removed is I used to have this whole bit here, which would have represented this angle over here. This bit's gone. I'll call that beta, gone. So the 2 red bits are gone. And convince yourself those 2 red bits are gone, but we've now got, because we've got k plus 1 sides, we've now got an extra side. So we've gained something here. So we've gained this guy here. So comparing the 2 diagrams, hopefully you can see we've lost alpha and beta, but we've gained gamma. Okay, so let's do a little bit of writing. Okay, so k plus 1 this side, it loses alpha plus beta, but gains gamma for the exterior sum. So therefore, to remain 360 degrees, the exterior sum to remain 360 degrees, we are required to prove that gamma must equal to alpha plus beta. The amount lost, the angles lost, should equal the angle gained. Okay, so that now becomes what we're required to prove. Okay, and in order to do this, what I'm going to do is I'm going to put a little dot here, and hopefully you can see quickly that I'm running out of room. That's all right. Firstly, dot, I'll go over here. Dot will equal to alpha. Why? Because vertically opposite angles are equal. I'll zoom out a bit. Vertically opposite angles are equal. And also, the exterior angle should equal the sum of the two opposite interior angles, which means that gamma here will equal to dot plus beta. Exterior angle of triangle is equal to the sum of the opposite interior angles of the opposite interior angles. That's just exterior angle theorem written out. And because we know dot is equal to alpha, so therefore gamma will equal to alpha plus beta. As dot equals alpha. Okay, as required. So I've shown that when I've moved from the kth case to the kth plus 1 case, I've lost these two angles but gained gamma, and I've shown that what I've gained is equal to what I've lost. So therefore, well, that completes the proof. I've shown my RTP, that completes the proof. So I can therefore write, therefore if true for n equal k, then true for n equal k plus 1. Therefore, by the principle of mathematical induction, the result is true for all integers n greater than or equal to 3.